All right. I'm Andrew. I'm a first-year PhD student in the CCA, being supervised by Arya. And as part of the CCA, I was lucky enough to work for Cantab and Chris. And I would like to, in the next 5 minutes, kind of add a little bit of information to one of the topics Chris mentioned in his talk, which was shipping data. So in his talk, we saw a lot of nice pictures of the AIS shipping data. And a question is, how do we use this data? So the first thing we want to do is get a big picture of what's going on. So we want to say, can we qualitatively find some trends that we can kind of exploit quantitatively later? And I think it's very interesting here that you kind of see a little bit of that cautionary tale Chris was talking about. A lot of stuff is going into China. And it's only through graphs like these that you can see these kinds of trends developing. But we want to see what we can say quantitatively, so we look at some quantitative tests. And the simplest of these is the Kolmogorov-Smirnov test. And this can be used to tell whether two samples are coming from a different distribution. And naively, you would think that a ship coming into port would mark a major event. So a ship comes into port, sells a lot of coal, you would expect price of coal to be affected by that. So we're going to use the KS test to see whether the distribution before a ship arrives at port is different from the distribution of prices after. And this can be done through what's called a markout test. So if you think of the origin as the event of a ship coming into port, you have a distribution of prices before and a distribution of prices after. And these are all averages of a bunch of journeys, and this is an example of coal coming into Rotterdam. And so we can use the KS test to say whether the stuff on the left is different from the stuff on the right. And you can kind of see with your eyes that they're very similar. So we have to result, and the KS test tells you that they are not coming from different distributions. So we have to resort to more powerful machinery, and this is where we bring in the RNNs that Chris talked about earlier, so I won't spend too much time on those. This is the same thing that Chris showed us earlier, and I want to emphasize two things. So first is that they're useful for sequences like financial data, but they do suffer from something called long-term dependencies. And that means that it'll only be using relatively recent information to be making the next step. So if your system in the real world will depend on something from a long time ago, you may not get to see that coming up in your recurrent neural network. So that's solved by something called a LSTM, which is a specific form of RNN. And the way it addresses this problem is through the cell state, which is the kind of a line running across the top there. And I have a lot more information about this on my poster if you're interested. But basically, the cell state acts as kind of a conveyor belt, which pushes information through the system. And all of these nodes below it are deciding what do we want to forget from our cell state, and what new information should we add to the cell state, and then what do we pass on to the next node as an input. So now we bring all of this and apply it to shipping data. So this is going to be the same kind of in-sample training that Chris showed us earlier, except it's being applied to shipping data. So we're using shipping data in past coal prices to predict coal prices. And what's really nice is that we start to see very fast in-sample convergence. So the green is our prediction, the blue is what actually, those are the actual prices. But Chris kind of mentioned two things in his earlier talk, and one is that does this beat the models that we have, and two, can we use this to predict out of sample? And so as we saw in the weather data, weather actually made a good impact in helping predict power data, but in this case, shipping data didn't really make much of a difference. So you could have just used previous coal prices to predict future coal prices. And the other thing is this didn't really do too well out of sample, maybe because we only had 2 years of data and maybe there was some problems with the richness of the data that Chris mentioned earlier. That could be one reason why. But that's it, so thank you very much.